So this is a circuit diagram of an comparators. So here you can observe I used the op-amp 741, MU 741, and the two inputs are, one is non-inverting input, other one is inverting input. For non-inverting input I given a DC voltage of 5 volt. For inverting input, so I connected one potentiometer pot, 10 kilo ohm pot, and one terminal of the pot is connected to the 10 volt, other terminal is connected to ground, and the third terminal is connected to the inverting input of an op-amp. And the pin number 6 is output, and pin number 7 and pin number 4 is connected to plus VCC and minus VCC. So here the working of the circuit is I vary this input voltage by varying the potentiometer, and this potentiometer, the one terminal is connected to 10 volt. So by varying this potentiometer I can change the voltage from 0 to 10 volt. Now while comparing, when this voltage V in the voltage at the inverting terminal, if it is less than the fixed voltage, that is reference voltage 5 volt, the output will be plus V saturation, because as I mentioned it is an inverting comparator, so the output will be plus V sat. So we will get 12 volt in this case, because maximum voltage is 12 and minus 12 volt. When V in is greater than 5 volt, I mean this voltage at the inverting terminal is greater than 5 volt, the output will be minus V sat, that is here minus 12 volt. So this is about the basic working of the comparator circuit, and here this circuit is in open loop configuration. I have not used any feedback. So the main application of this circuit is, and you can use it in zero crossing detector, the window detectors and all. So those are the application of the comparator circuits. So the same circuit I have connected here, and now we will check the output by using multimeters by varying the pot. And I used here two multimeters, one to check the voltage of input, that is the voltage at the inverting terminal, and the other multimeter to check the output. Now this is a op-amp. The op-amp here 1, 2, 3, 4. The pin number 2 is connected to the potentiometer. The one terminal of the potentiometer is connected to the pin number 2, and the one terminal of the potentiometer is connected to the plus 12 volt. Because pin number 7 is connected to plus 12 volt, and pin number 4 is connected to minus 12 volt, and the terminal is connected to ground. And the other terminal of pot is connected to ground. This is the potentiometer. And pin number 3, the pin number 3 is the non-inverting input, which is given to the, it's connected to 5 volt, and the negative of that is connected to ground. So this is a common point where all the ground terminals are connected. Now as I mentioned, the two multimeters are used here. This is to check the input voltage, and this one is used to check the output voltage. Now as I mentioned, when voltage is less than 5 volt, we are expecting the output as plus 12 volt. When input voltage is greater than 5 volt, we are expecting the output is minus 12 volt. Now here, so I will vary this pot. You can observe here, we can change the output voltage from 0 to 12. So here I can observe now the voltage is greater than 5 volt. Here I considered 9.5. So I am expecting the output voltage as minus V sat. So you are getting around minus 11.7. Now I will just change it. I will make it less than 5 volt. The potentiometer values I will change. So you can observe here, so if the voltage is less than 5 volt, you are getting a plus V saturation. So around 11 volt you will get. So when Vin is greater than 5 volt, minus 12 volt. When Vin is less than 5 volt, we will get plus 12 volt. So this is just a comparator. It's comparing the voltage across inverting terminal and non-inverting terminal. And mainly this potentiometer is used to vary the input voltage, that will vary from 0 to 10 volt. So this is about the output of an comparator circuit using op-amp. Thank you.